Hello, am I audible and is my screen visible? Please someone let me know. Hello.
Yes, sir. Yes, sir. Audio.
Okay. Okay, thank you. Good evening everyone. Welcome to this NPTEL live session for the course Introduction to Machine Learning. My name is Awan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is my ninth live session, and in this live session I will discuss some problems on week 9 topics which were mainly based on undirected graphical models. So I will discuss some problems on these topics, and I will also try to answer your questions and queries if you have any. If you have any questions or queries, you can let me know during this session. So we will start solving the practice problems first. Then if you have any questions, you can ask me. This is the first question. Consider the Bayesian network shown in this figure. Two students, student A and student B, make the following claims. Student A claims that probability of A given B and D equals probability of A given D, and student B claims that probability of A given B equals probability of B. So which of the following is true? So you have to find out whether both the students are true or one of those students are true. And this is the Bayesian network. You can you can write your answers in the chat. VG Satish is option C. Okay. Anyone else? Orijit Saha is also saying option C, which is student A is incorrect and B is correct. Okay, so in this question, the first claim is that probability of A given B and D equals probability of A given D. So it basically says that A and B are independent given D. So it basically says A and B are independent given D. And the second claim is probability of A given B equals probability of B, basically means probability A and B are independent given no evidence. If no evidences are given, A and B are independent. So this is the this is the Bayesian network. So first claim is A and B are independent given D. So here is A and B, and this node D is given. So in this case where C is the common child of both the nodes for which we have to find out the independence A and B. If C or any of its descendants is given, in that case this path is not blocked. So if C is given, this path is not blocked. If D or E is also given, this path will not be blocked. So A and B will be connected. So A and B is connected if D is given. So if A and B are connected, then A and B cannot be independent of each other. So first claim is wrong. And second claim is probability of A given B equals probability of A. That means A and B are independent without any evidence or without any given variable, observed variable. So A and B, so in this case now nothing is given. You have to find out the independence of A and B. So if C or any other nodes are not given, in that case this path is blocked. So this path will get blocked at C. So A and B will be A and B are independent if no other variables are observed. So student B's claim is right. So correct answer would be option C. The student A is incorrect and student B is correct.
Sir, please explain the function probability of A given B comma D equal to probability of AB given D. How can we
Yeah,
write that like that?
this one. Which one are
First,
you asking?
first, first, student A claims probability of A given B D equal to probability of A given D.
Yes.
That implies probability of A comma B given
No,
D.
no, I'm not saying
How
this
can
is.
we?
I'm not saying this is probability. I'm just writing it that this student A's claim basically means A and B are independent if B is given. This is, I'm just stating what A is claiming. I'm not saying it is probability of A comma B given D. It's not that. I'm just writing it that student A claims that A and B are independent given D. This is what first claim is, and this is what we have to check from the Bayesian network, that whether A and B are independent or not given D. Is it all right?
So please explain once again.
So
Probability of
forget
A
this one.
given D.
This is the claim probability of A given B comma D equals probability of A given D. That basically means the B is skipped in the right hand side, right? B is not there in the right hand side. It is only probability of A
Yes.
given D. So basically means A is independent of B if D is given. D is given in both the left hand side and right hand side. So
Okay, sir. Okay.
So A is independent of B, that's why B can be omitted from the probability value completely. A is independent of B if D is given. So this is what first claim is. Similarly, second claim is that probability of A given D, A given B equals probability of A, second claim. So it basically means A and B are independent if no evidence is given. That's why B is not required in this probability value. It is only probability of A. So B is independent of A and also A is independent of B. This is the second claim.
Okay, sir. Thank you.
So correct answer would be C, that A is correct and B is incorrect. Now second question. In the undirected graph given below, which nodes are conditionally independent of each other given B? And multiple options may be correct in this case. So this node B is given and you have to find out which pair of nodes are independent of each other given this node B. and this is an undirected Bayesian network. Ritika Kestri says option E, Arch says option D. Okay. VG Satish is saying option E. The first option, basically you have to check for every option whether that pair is independent of or not given B. The first pair is A comma D. So here is A and here is D, and this node B is given. So we have to check whether we can find at least one path from A to D which is not blocked by B. As this is an undirected graph, so we don't have to worry about the direction of the edges or arrows. So we just have to find out at least one path from A to D that is not going through B. Then we can say A and D are not independent. If all the paths are blocked by B between A and D, then A and D will be independent of each other. So I can already see this is one path, A to C, C to E, E to D. So this path is certainly not blocked by B, and I think this is the only path that is not blocked by B. So if we find at least one path that is not blocked by the node that is given, in this case it is B, then these two nodes are not conditionally independent. So this is not conditionally independent. Second option is D and D. So this is D and D. So D and D has this direct edge from D to A and also E to D. So if there exists a direct link, then those two nodes are always dependent on each other. They cannot be independent. So this is not correct. Third option is C and D. So C and D. Again for C and D, this is the path that I can find out, which is not going through B. C to E and E to D. This path is not blocked by B. So these two nodes are also not conditionally independent. And the final option is A and F. So A and F, and this path is there, A to C, C to F. This path is not blocked by B. So these two nodes are not independent of each other given B. So this is also not right. So none of the above would be the correct answer here. Option E. And most of you have written option E. So this is the correct answer. Now question 3. In the undirected graph below, how many terms will be there in its potential function factorization? So this is the undirected graphical model given here, and you have to find out the number of terms in the potential function factorization. Basically, how many factors can we find out using potential function factorization? If we use maximal clicks, so that part is I forgot to write that part. So if we use maximal clicks, then how many terms will be there in its potential function factorization? Orijit Saha says option B. Okay.
So, can you explain the maximal click? What you say? What does that mean?
So maximal click basically means subgraph of the graph, basically subset of the nodes of the graph, where every node is connected to every other node directly. So for example, in this case, option B would be the correct answer. So maximal click, to find out the number of terms in the potential function factorization, so we have to find out maximal clicks here. If we use there may be number of different potential function factorizations. So in this case, we are talking about only maximal clicks. So this is one maximal click. This A, B, C, D, this subgraph of this whole graph is a maximal click because every node is connected to every other node in this subset only. A, B, C, D. A is connected to B, C, D. B is also connected to all other three nodes. C is connected to all three nodes. D is also connected to all the other nodes. So that's why this is a maximal click. This is the first factor of this factorization, and the second one would be this is another maximal click. ADE. ADE, all the nodes are connected to each other. A is connected to ED, D is connected to AE, AE is also connected to AD. This is the second factor, and this is the third factor, BCF. BCF, all the nodes are connected to every other node. So these are the three maximal clicks, and these are the three terms that we can find out in potential function factorization. ABCD, AED, BCF. These are the three terms we will have in potential function factorization. So now option B 3 will be the correct answer. Option B 3 will be the correct answer. Option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the correct answer. So now option B 3 will be the corr Is it understandable? Okay, now I move on to question 4. Consider the following Bayesian network. A small Bayesian network is given with 3 variables, and different probability values are also given here. Probability of r, probability of s, probability of w given r comma s. So this is r, this variable is s, this variable is w, and you have to calculate probability of s given w comma r. And this negation of s, this basically means complement of s. Orijit Shah is saying option C, 0.22. Okay. VG Satish is saying option C. So to find out probability of s given w comma r, we have to use Bayes theorem. So we can write it as w probability of s comma w comma r divided by probability of w comma r, and we can rewrite it as probability of because we were given probability of w given r comma s, w given r comma negation of s. So this way we can split this numerator as w given s comma r into probability of s comma r divided by probability of w given s comma r, probability of s comma r, plus probability of w given s comma r, probability of negation of s comma r. So this is the probability that we have to find out, and probability of s comma r is probability of s into probability of r, because s and r are independent of each other. So probability of s comma r is just probability of s comma into probability of r, and all these probability values are given. So this probability of w given s comma r is given here, and probability of s and r are given here. Probability of w given negation of s r, this is also given here. So all these values are given. We just have to put these values into this formula to find out probability of s given r, and the correct answer would be C 0.22 and the process is also shown here. Question 5, what is the naive assumption?
Sir,
Yes.
1 minute, sir. Sir, as we know the base rules, probability of A given B equal to probability of B given A into probability of A divided by probability of B. So how you derive this in this problem with
So
two given things?
we have to find out probability of a is given w comma r.
W comma. Yes.
So now we can write it simply. So probability of a given b is probability of ab divided by probability of b. First, this is the thing. Then
Okay.
probability of ab can be rewritten as probability of b given a into probability of a divided by probability of b. This is how we get the
Yes.
final formula for the Bayes theorem.
Yes.
So
Yes.
first we write it as probability of a comma b divided by probability of b.
That I understood. The second step I didn't understand. How you write here?
So here
This.
probability of s given w comma r, we will write it as the joint distribution of all the variables
Yes.
s comma w comma r divided by probability of b would be the denominator. B is here w comma r. So
Yes.
w comma r.
Yes.
Now then probability of s comma w comma r, this numerator part, we can write it as just this second step in the Bayes theorem.
Yes.
So we put one variable in front and given the other variables
Okay.
into probability of the other variables s comma r.
So can we write this with R given SW?
Yeah, we can write it same in the same way as s given r given w comma s into probability of w comma s. We can write that, but it is not required,
Given
because
here.
the probability values we are given is for
Yes.
all
Yes.
only for the
Under,
w's.
understood. That
So we
means
will
the
split it
values
as
are
this.
given that this way. That's why we have write this. So both are correct.
Yeah,
Actually.
uh, you can write it as w given the other variables, or r given the other variables, or even s given the other variables. But we
Yes.
need only w given the other variables because that value is known to us.
Yes.
Yeah.
Okay. Thank you.
Now question 5. Which is the naive assumption in a naive Bayes classifier? Option A is all the classes are independent of each other. All the features of a class are independent of each other. The most probable feature for a class is the most important feature to be considered for classification. Option D is all the features of a class are conditionally dependent on each other. Jayanti says option B. All the features of a class are independent of each other. Okay. Ajay Chauhan says option B. Ritika Kejri says option B. Arijit Saha also says option B. So the correct answer is option B. That the naive assumption in naive Bayes classifier is that all the features of a given class are independent of each other. So basically, if we have x1, x2, xn features, so probability of x1, x2, xn given C, if the class is given for a given class, it is simply probability of x1 given C into probability of x2 given C up to probability of xn given C. So product of all these individual probabilities. So x1, x2, x3, xn, all these variables are independent of each other given the class. So all the features of a class are independent of each other. Now question 6. A spam filtering system has a probability of 0.95 to correctly classify a mail as spam and 0.10 probability of giving false positives. It is estimated that 1% of the mails are actually spam mails. Suppose that the system is now given a new mail to be classified as spam or not spam. What is the probability that the mail will be classified as spam? Arijit Shah says option C, Vijay Satish says option C. Archer says option C. So to solve this question, we need to state two random variables. So let's consider S, which is classified as spam by the spam filtering system, and M is actually spam. So what we have to find out is that probability of S, we have to find out what is the probability that a given mail will be classified as spam, and the information that are given to us is that first is this probability of 0.95 to correctly classify a mail as spam. So this probability is basically probability of M given S. sorry, no, it is probability of S given M, that if a mail is actually spam, then what is the probability that it will be correctly classified as spam. And then there's 0.10 probability of giving false positives, basically means if it is not a spam, what is the probability that it will be classified as spam. So probability of S given M complement. And it is estimated that 1% of the mails are actually spam mails. So this 1% is probability of M. So to find out probability of S, we can use the total probability theorem, which is S given M into probability of M plus probability of S given M complement into probability of M complement. So this S given M is given as 0.95, probability of M is given as 1%, which is 0.01, probability of S given M complement, which is false positives, probability is 0.10, and probability of M complement, probability of M is 1%, so probability of M complement will be 99%, that is 0.99. So if we put these values into this equation, we will get probability of S, that is what is the probability of that the mail will be classified as spam, and the correct answer would be option C. Now question 7, which of the following graphical models capture the naive Bayes assumption where C is C represents the class level and Fi are the features. Ritika Kestri says option A. Orijit Saha says option A. In naive Bayes, features are independent given the class. So if features are f1 or f2 fn, so the probability of f1 f2 fn given c equals probability of f1 given c, probability of f2 given c, up to probability of fn given c. So these feature values only depend on the class level, all these feature values. So class level would be the parent node or the root node, and f1 f2 fn, all these features would be dependent on that node. So direct edges would be there from c to f1 f2 fn. So option A is the correct answer. So the Bayes assumption states that given the class level, the features are independent. This is captured when class level is the parent node for all the feature nodes. Now question 8. Consider the Markov network shown below in the figure. Two students, student A, student B, make following claims. Student A claims that probability of A given B equals probability of A. Student B claims that probability of A given B comma C equals probability of A given C. So which of the following is true? And this is an undirected graphical model. So there are no directions in these edges. It's an undirected model. Orijit Saha says option B. Harapriya Kaur says option B. Ritika Kestri says option B. Jayanti says option B. Ajay Chauhan says option B. Yeah, so all the answers in the chat are option B. So first claim is probability of A given B equals probability of A. So A and B are conditionally independent of each other. That is what this claim is. So A and B, this is an undirected graphical model. So this path we can easily see from A to B. No other variables are given. So there is a path from A to B. So A and B are not conditionally independent of each other. So this first claim is wrong. Second claim is probability of A given B comma C equals probability of A given C. That is, A and B are independent of each other given C. So if this node C is given, now whether A and B are independent of each other. So if C is given, this path gets blocked at C between A and B. There is no other path from A to B. C is blocking this only path. So C blocks this path from A to B. So A and B are independent of each other given C. So this second claim is correct. So correct answer would be student A is incorrect, student B is correct. So option B is the correct answer. Now question 9. Consider the Markov network shown given below. Which of the following variables are not in the Markov blanket of the variable 4? So this is the variable 4. So which of these variables will not be in the Markov blanket of variable 4? Odisha says 5C, 5 and 7, and Harappriya Kaur says DG, which is 5 and 7. Ritika Keshri says 5 7. Vijay Sathi says 5 7. Ajay Chauhan says 5 7. Archer says D and G, which is 5 and 7. So in undirected graphical models, the Markov blanket of a given variable is just the neighboring nodes of that variable. So in case of 4, the neighboring nodes are 1, 2, 3, 6 and 8. So these are all the immediate neighboring nodes of 4. So these nodes form the Markov blanket of 4. So only 5 and 7, these two nodes are not directly connected to 4. So these are not direct neighbors of 4, 5 and 7. So these two nodes will not be present in the Markov blanket of 4. So 5 and 7, D and G are the two correct options there.
Sir, what will be the answer of 8? Uh, Markov blanket of variable 8.
8 is only connected to 4. So 4 is only present in the Markov blanket of 8.
That means 1, 2, 3 all
All
should
the other
be.
variables will not be in the Markov blanket of 8. So only
No,
the neighboring nodes will be in the Markov blanket.
so 1 is also neighboring node of 8.
1 is not neighboring, only the immediate neighbors. So
Then
4
that
is the
means
only immediate neighbor. No,
so the answer will be 5 and 7 for 8.
for no, 8 8 is 8
Instead
is
of
connected
4.
to only 4. There are no other edges for 8, right?
Yes, yes.
So only 4 will be there in the Markov blanket. All the other variables will not be in the Markov blanket.
So the question is in the Markov blanket of variable 8, which is the following is not the connected.
Yeah, only the neighboring nodes will be in the Markov blanket. Only the neighboring nodes form the Markov blanket. All the other variables are not in the Markov blanket. For 8, there is only one edge to 4, isn't it?
Yes.
So the Markov blanket of 8 is only 4. That's it.
5 and 7.
5 and neighbor means basically you have a direct edge to that. Not
Uh,
like you can see that 5 and 7 are near to each other. Not like it is situated near 5 and 7. You have to find out the edges that are going to the other variables. 8
so
has an
not
edge from 8 to 4.
so not in the Markov blanket of 8. Then the answer will be 7 or 5, 7 5 or 1 2 1 3 7 5 2 all.
Apart from 4, all the other variables are not in the Markov blanket.
Okay.
Only
Okay.
4 is in the Markov blanket. All the other variables are
Okay.
not in
So
Markov blanket.
my doubt is 1 is also the neighboring node of 8, which is
No,
not
no, no.
directly
No,
connected to it.
it is not directly connected. It is connected via 4, 8
Mhm.
to 4, 4 to 1. This is the path from 8 to 1. But direct edge is not present. Only one edge is present, that is between 8 and 4. So immediate neighbor. Not you can find out second degree, third degree neighbors. Those don't matter. Only the immediate neighbors are in the Markov blanket.
Okay.
So D and G 5 and 7 are the two correct answers, sir. Oh, sorry, 5, D and G 5 and 7. Now question 10. In the Markov network given below, so the same network I am using, two students make following claims. Manish claims variable 1 is dependent on variable 7 given variable 2, and Trina says variable 2 is dependent on variable 6 given variable 3. Which of the following is true? So this is an undirected graphical model. Harapriya courses option B. Ajay Chauhan says D, Vijay Satish says D. So the first claim is that variable 1 is dependent on variable 7 given variable 2. So this is 1, this is 7, and this node 2 is given. This is an undirected graphical model. So we just have to find out whether there exists at least one path from 1 to 7 which doesn't go through B. Then those two nodes are not conditionally independent. So basically all the paths from 1 to 7 go through 2. Yes, all the paths like 1 to 2, 2 to 7 is another path, which is 1 to 2, 2 to 5, 5 to 7. This is also going through 2. So every path will go through 2. So, and if 2 is given, 2 blocks all the paths. Variable 2 is given, so 2 will block all the paths, and 1 and 7 are conditionally independent of each other. So this says dependent on each other, this claim is, so first claim is wrong. And second claim is 2 and 6 given 3. 2 and 6 given 3. So it is says 2 is independent of 6 given 3. So between 2 to 6 I can already see this one path which doesn't go through 3. 2 to 4, 4 to 6. So this path doesn't go through 3. So 3 doesn't block this path. So 2 and 6 are dependent on each other. They are not independent of each other. So this claim is also wrong. So correct answer would be D. Both students are wrong. Both the claims are wrong. So option D is the correct answer. So these were the questions that I wanted to discuss in this live session. So now if you have any other questions or queries, you can ask.
Sir, I have one query.
Yes.
In the factorization of Markov undirected graph, you have discussed, I think, question number 4 or 5.
Yes.
Can we so
Okay.
question number 4 or 5? I think
Yeah,
this
this
one,
question. Yeah.
sir. The maximal we taken A, B, C, D,
Yes.
and remaining two nodes are there E and F. Can we consider individual single node as a function? So function one A, B, C, D dot function two only E and function three only F.
Mm, I don't think that can be done. Uh, because in that case, I'm not completely sure, but if let's consider this is the uh, E and F. So E and F are not connected to any other nodes like this. This is the uh, undirected graph. All right. Even in that case, then we will say that A, B, C, D would be one factor and E and F will be two other factors. But
Yeah.
these two graphical models are not equal, isn't it? Because in the left, E is connected to A and D, and F is connected to B and C. So we need to consider these connections as well. But in the right figure, we can see that E is completely separate from all the other nodes, and F is
So if
completely
we
separate.
consider a vector with a particular node, so we have to consider all the nodes connected to that particular node. Suppose I consider this E, so it must be considered with A and D also.
A and D. No, D is not connected to E.
D is
Oh,
connected
sorry,
to
sorry.
E.
D, yeah, D is connected to E. Yeah, so that's why this is another. This is one click that maximal click that we have to include in the factorization.
So
EAD. All the
there
nodes
may be
in
some
this.
other factorization of this.
Mm,
If I consider B, D, and C,
BDC. Yes, this is one click. Uh,
can we use this? Or B, D, C, F, one factor, and another factor is B, D, E, A. Only two factorization, two factors are sufficient.
Generally, we go with the maximal click. So that's why the question I have given is that how many terms will be there if we use the maximal clicks. But if we use only different other clicks, there are many other clicks here which are not maximal in nature.
So
Uh,
in this, if I consider one click B, D, and C, F,
BDCF. BDCF is not a click because D and F are not connected. Click means every node should be connected to every other node in that subset of nodes.
okay.
D and F are not connected. That's why ABCD is one maximal click, but every node is connected to every other node in this ABCD part only, and it cannot be extended. That's why it's called maximal click. So it is maximal. But BCD, this is one click. It is not maximal in nature because we can also include A to it. It will still remain a click. So that's why it is not a maximal click. BCD is not maximal, but whether we can use clicks that are not maximal in nature in factorization, I am not completely sure, because generally we go with maximal clicks, but it might be used for other factorizations, but I am not completely sure about that.
So can we further factorize this A, B, C, D?
further factorize, mm, it is possible, but I don't know whether that is allowed or not. I have to study about that in detail. I don't exactly know right now that whether we can split that uh, maximal clicks farther or not.
Okay.
I'm not completely sure right now.
So for a given network, different factorization are
Different
possible.
factorizations might be possible, yes, but whether other clicks can be considered as factors or not, that I'm not completely sure.
Okay.
And also that you said that E and F could be considered separately or not, that is also I'm not completely sure. I have to study in detail about that. Right now I'm not completely sure.
Okay. Thank you.
Okay. Is there any other questions or doubts? Okay, if there are no other questions or queries, then thank you everyone for joining. We can end this live session now.
Sir, without maximal click, how can we factorize this graph? That graph what you have shown now.
That I told that I'm not very sure about that. That without using maximal clicks, whether we can do that or not.
Maximal click means maximum number of nodes
So
should be in.
click means all the
Every
nodes
node
are
should be
connected to
connected.
all the other nodes in for that set of nodes only. Like in that case, ABCD, all the nodes are connected to all the other nodes among
Yes,
ABCD. And
yes, yes.
maximal click means we cannot extend it any further. That we cannot add any other node like E and
Maximum
F.
number of node will be included.
Yeah,
So
E
can
and
be
F,
included.
those two nodes cannot be included in that click to extend it. So it is maximal in nature.
And in factorization, can we take a single node also?
Yeah, that I said that I am not completely sure about that. Maximal
Okay.
clicks can be used, but whether other clicks can be used or single nodes can be used, I am not completely sure about that.
Sir, can you show the that slide again?
So in factorization, that
Yes.
it is mandatory that all the nodes should be connected in factorization.
All the nodes should be. I mean the
Suppose
this
we
right figure
factorize,
I am showing that E and F are not connected at all. So this can be one undirected graph, but factorization would be different for this.
so we can factorize E and F together or E separate or F separate. That is the question.
So
Sir,
as per my understanding for this graph, it would be factorization would be A B C D E separately, F separately for this right hand side graph. So
Okay.
because E and F are not connected to each other, so they can be separate factors. E and F are not connected to any other nodes. So as per my understanding, I think this one would be right, but I need to check it further. That E and F are not connected to any other node, so E and F should be mm, uh,
And if
independent factors.
the main figure, how you factorize?
So for this that I told you that you have to find out the clicks. First is the largest maximal click is the ABCD.
No, that I understood.
Then
Without maximum,
for the other nodes, you have to find out the other clicks. So E and F are not connected, are not included in the first click that we found out ABCD. So how we can include E to this factorization? So the one click, that is one maximal click that includes E, is AED, and one maximal click that includes F is BCF. So that's why we find out three different maximal clicks in this to include all variables.
sir, suppose in this network, one more node is given, which is connected to C only. So consider one another node G
Yes, like this.
connected to C.
Hmm.
So for this, we have to consider one more factor, that is CG.
CG, yeah. Hmm. So basically, it is each factor would be a click. So as per my understanding, each factor should be a maximal click. So this is CG is also one maximal click here.
It contains only two nodes.
Yes, I think this would be the the factorization for this. But uh,
So, but C F G we cannot do because FG is not connected, no?
now FG are not connected, so we cannot put FG as one factor. CG is
No,
connected to, so CG.
CFG we
CFG,
can.
can we take CFG?
So no, CFG we cannot take because F and
F
G
and
are
G are not
not
connected.
connected. So this does not form a click.
So click and factorization of both are the same thing.
Yeah, each factor should be a click. Uh, but other factor, whether other kinds of factorizations are possible or not, that I am not completely sure about that. Was there any example given in the video lectures for any specific
They
thing?
No.
give given a simple example of four nodes.
Yeah, I have also seen that no specific examples were given for complex networks, but there is a question in the assignment regarding that. So yeah, I'm not completely sure about the what different kinds of factorizations are possible. For this, I can find out that three maximal clicks are there. So obviously, maximal clicks should form factors, but whether other clicks can form factors or not, that I'm not completely sure.
So one more question within the two factorization in a figure.
Yes.
So one node should be common, no? So
Uh,
suppose A, B,
yeah.
C, D and C, G. So C node is common. So this connecting node C with this two factorization.
C, yeah, C can be common to multiple factors actually, not just two factors. C can be common to multiple factors. If C is part of three different maximal clicks, it would be part of three different factors in that case.
Suppose here A, B, C, D one factorization, then A, D is another factorization,
Hmm.
B, C, D, B, C, F one another factorization, and C, G as another factorization.
Yes. Yeah, so C is part of three different factors now.
And now you see, if you see that BCF and ADE are connected by ABC, CD, common nodes,
Yes.
and the whole thing is connected by CG with the common factor of C.
Yes. Yeah,
So
so
there should
C
be
is
a
connecting three different clicks here. So
between two factorization, we should have at least one common node.
yeah, this can be right.
Otherwise, how it will be connected?
Yeah, this is why have shown you this right hand side figure, that if E and F are not connected, then E and F would be completely different factors.
Sir, is there any condition to minimum number of factor or maximum number of factor?
Mm, I don't completely know, but if we form the factors based on maximal clicks, I think it would give you the least number of
Minimum
factors.
number of factors.
Yeah, I think so, but theoretically whether it is correct or not, I don't know. But this is what I think, that if we find the maximal clicks, obviously that should
Minimum
give you
number.
the minimum number of factors.
So this ABCD can be write is in two different form, ABD and BCD.
A, B, D, B, C, D. Yeah, that's what I'm saying you, that maximal clicks we can use, but whether clicks which are not maximal, ABD is not maximal, it is click. It is not maximal click. So whether we can use that in as a factor or not, that I am not completely sure.
Okay. Thank you very much.
Okay, thank you everyone for joining.